Good morning, everyone. Today we will be presenting our project titled Locally Adaptive Intelligent Technologies for Real World Autonomous Driving. This project explores how AI can move beyond generic intelligence and become deeply human centered and locally aware, especially in the context of autonomous mobilities. This presentation is prepared by as me, myself, Subhana Dawi, daughter of Sarnamurthy, and my partner Joanna, daughter of Murugesan, for Master Entrepreneurship under the guidance of YM Professor Dr. Haji Raja Suzana Raja Kazim. Abstract. At the core of our project is one key idea. Autonomous vehicles should not just see the road, they should understand it. This study focuses on local adaptive AI chips inspired by Horizon Robotics, designed to learn from real human driving behavior, regional traffic horns, and environmental conditions. We deeply design thinking to ensure these technologies are not only advanced but also empathic, culturally relevant, and practical. By integrating on chip intelligence, sensor fusion, and processing, we aim to improve safety, trust, and real world performance in autonomous driving system. About the company. Horizon Robotics is recognized as one of Asian leading pioneers in edge AI computing, particularly within the field of autonomous driving and smart mobility. What truly differentiates Horizon Robotics from many other AI companies is its philosophy of intelligence. Instead of measuring intelligence purely in terms of processing speed or computational power, the company focus on behavioral intelligence, and it is how system perceived, interrupt, and respond to real world situation in a human like a way. At the core of this approach, Horizon Robotic Prototype Brain Processing Unit or BPU, unluckily conventional processor that handle data sequentially. The BPU is designed to mimic how the human brain works. It integrates real-time perception, multi-sensor fusion, and low latency design making directly at the edge and inside the vehicle itself. This means the system does not really heavily on cloud processing, which can cause delay. Instead, the vehicle is able to see, think, and act almost instantly, similar to how a human driver react on the road. Most importantly, Horizon Robotic does not design AI that expect humans to change their behavior to suit technology. Rather, the company develop AI that learn from human driving behavior, adapt to local traffic cultures, and respond empathically to real-world conditions. In this way, Horizon Robotics position itself not just a technology provider but as a human centralized AI innovator, bridging the gap between advanced computation and real human experience. Next, we move to vision and mission. Horizon Robotics' vision is to create autonomous systems that think and adapt like humans rather than simply follow programmed rules. Its mission focus on shifting AI from generalized intelligence to localized intelligence. This means developing AI that understanding cultural driving habits, environmental conditions, and regional road behaviors instead of applying a one size fits all model. By doing so, Horizon Robotics follows a human centralized innovation approach, ensuring that technology supports people, communities, and cities in a natural and trustworthy way rather than forcing humans to adapt to technology. Project background. Autonomous mobility is advancing rapidly across the world, supported by breakthrough in artificial intelligence, sensor, and computing power. However, despite this progress, AI systems still struggle when they are exposed to real world driving complexity. The key issue is that driving is not only a technical task, it is a social and conceptual activity. Different regions exhibit very different driving behavior. For instance, in a Kuala Lumpur, traffic is decent and highly unpredictable, with the frequent lanes changing and mixed road usage. In Jakarta, roads are dominated by motorbikes, requiring vehicle to constantly activable sudden movement. Meanwhile, Beijing cooperate under high speed and high volume conditions where a rapid decision making is critical. Traditional autonomous AI systems often fail in this environment because they are trained and generic data set and designed using standardized assumptions. As a result, they treat all roads as they are the same, ignoring culture horns, infrastructure difference, and human behavior patterns. This creation is significant gap between laboratory performance and real-world reliability. This project is built on Horizon Robotic core belief that local intelligence is the missing link in autonomous mobility. AI must go beyond object deduction, such as identifying cars, pedestrian and lands, and move toward conceptual understanding. By learning how people actually drive in specific environment, autonomous system can behave more natural, more safety, and more reliability. In this way, local intelligence become essential for bridging the gap between technological capability and real world application. Product and service. Horizon Robotic does not operate as a single product company. Instead, it offers a complete AI ecosystem designed to support the entire autonomous driving journey from perception to design making and development. At the hardware level, Horizon Robotic develop high performance AI chip especially engineered for edge computing. This chip enabled to real-time processing inside the vehicle, allowing immediate response without relying heavily on cloud connection. In addition, the company provides advanced sensor integration combining input from cameras, LiDAR, and radar. This multi-sensor function allows the system to build a more accurate and reliable understanding for the driving environment even in complex or low visibility conditions. Beyond hardware, Horizon Robotic offers software platform that transform a raw sensor data into meaningful perception in intelligent driving decision. This platform support functions such as object recognition and path planning and behavioral prediction. To support automakers and mobility pet partners, Horizon Robotic also provide development kits and consultation service, enabling customized integration and faster development. What truly differentiates this product and service is their strong focus and local driving patterns. Rather than rather than applying generic AI model, Horizon Robotic optimizes safety and efficiency based on regional traffic behavior, road condition, and environmental factors. This ensures that autonomous systems are not only technologically advanced but also locally relevant and reliable. Issue and problem. Despite rapid advance in autonomous vehicle AV technology, widespread deployment remains limited because the system face complex challenges in real-world driving environments. The primary issues are not due to hardware limitation but rather the inability of AVs to fully interrupt and respond to conceptual on the road. The key challenges included first, unpredictable traffic behavior, regional difference in driving culture, weather and infrastructures variation, and lack statement of the problem. The central challenges facing autonomous vehicle is not a lack of computational power or sensor substitution, but a deficit in local contextual intelligence. While current autonomous system can navigate, control, or similar or familiarly environmental effectuate, their performance deteriorate in unfamiliar region due to different in traffic ons, culture behavior, and environmental condition. Um, Geographical inconcentration, AVs may operate reliably in one country but respond unpredictable as elsewhere, creating safety risk for passenger and other road user. Scalability limitation. Without the ability to adapt to deserve driving culture and infrastructural variation, AV deployment remain constrained and preventing global adoption. To address gaps, there is a critical need for AI systems that are not only technically advanced in perception, decision making, and real time responsiveness, but also cultural and environmental adaptive, capable to interrupting local driving behavior, traffic patterns, and infrastructure conditions. Coincide the future of safe and scalable autonomous vehicle depends on context-aware intelligence AI that can understand and adapt to the subtleties of local environmental and bridging the gap between raw technological capability and real-world reliability. Importance of AI for horizon robotics. For horizon robotics, artificially intelligence is not intent of replace human drivers, but rather to augment of human-like design making in autonomous vehicle. The goal is not correct system that act as intelligent co-drivers, enhancing safety and reliability while navigation the complexity of real-world roads. Key contribution of AI includes first, interpreting complex sensor data. AI can process input from cameras, lidar, and radar on another sensor simultaneously, identify objects, road markings, and environmental cues with high perceptions. These allow vehicle to maintain situational awareness when it stands or chooses traffic conditions. Second, predicting human driving behavior. By learning patterns of human drivers, dictation and cyclists, AI can anticipate potentially unsafe actions such as a sudden lane changing or jailway walking or enable proactive and adaptive response. Third, responding in real time. Autonomous system equipped with the AI can make instantly decision under dynamic condition, balancing safety, efficiency, and complying with the traffic rules. Co-incident. In this framework, AI function as a co-driver supporting and enhancing human decision making rather than overriding it. This is a human-centered approach strength and public trust, improve safety outcome and position Horizon Robotic as a leader in context-aware autonomous driver. Next, restoring real-world reliability. Reliability remains a central challenge for autonomous driving. An AI system may perform flawlessly in controlled simulations yet fail when confronted with the complexity and unpredictability of real-world roads. Such systems, while technologically advanced, lack true intelligence. They are incomplete without conceptual awareness. Horizon Robotics addressed this gap by interacting machine learning with sensor fusion, creating systems capable of understanding intent. It means interrupting the action of other road users, such as predicting whether a pedestrian in about a cross or if a vehicle may merge unacceptably. Anti- Anticipation behavior. It's mean reconciling patterns in traffic and proactively adjusting driving strategy to prevent accident. Third, adapting to unpredictability. It's mean reacting dynamically to change in weather, road condition, or unforeseen event, ensuring constant performance outside simulation environment. Coincide by rehumanizing autonomy, horizon robotic ensure vehicle make intelligent contact away decision, bridge the gap between technical capability and real world reliability. Scalability through localization. Global deployment of autonomous vehicles is challenging due to variation in driving cultures, infrastructure, and environmental conditions. Simply replicating AI model across region often fail to account for these nuances. Horizon Robotic overcome this through predictive design and localization, enabling autonomous system to first analyze traffic data, infrastructure, and weather. It's mean understanding regional road condition and environmental factor to optimize performance. Second, incorporate regional behavior patterns. It's mean adapting to local driving ons, cultural tendencies, and legal requirements. Third, forecast operational strategy. It is predicting how vehicle should be behave in different settings to maintain safety and efficiency. Crow insect. Localization ensure that autonomous systems are scalable global without compromising local relevance and enabling vehicles to operate safely and reliably in deserved environments. Regional examples. Horizon Robotic demonstrate that autonomous AI can be locally intelligent, adapting to both cultural and environmental contexts. Example including Singapore. AI predicts conjunction and optimized line usage and reflecting highly regulated urban traffic patterns. Malaysia. Flexible speed control addressed unpredictable traffic behavior such as mixed vehicle types and informal driving practice. Japan. Snow aware braking and navigation ensure safety driving in harsh weather conditions. This case show that AI adapting goes beyond technical performance. It's understand local driving culture and environmental challenging, making autonomous vehicle truly contact awareness. Next, enhancing safety with predictive navigation. Safety underpin people trust is autonomous vehicles. Horizon Robotic employ AI driven predictive navigation to anticipate hazard before they materialize, transforming vehicles from reactive system into predictive intelligence. Key missions of included is historical accident data. It's mean identify high risk zone and behavior. Real time sensor input. It's also a continuously monitoring surrounding to detect sudden threats, and also regional traffic pattern. It helps to tailoring response to local driving horns and conjunction trends. Predictive navigation enhances safety proactively ensuring AVs makes informed anticipatory designs rather than merely responding to events. Following that, now we want to see optimizing efficiency and energy management. Efficiency is a critical complement to safety in autonomous driving. AI optimizes mobility by evaluating traffic flow, road type, and energy consumption to improve performance and sustainability. For example of region-specific optimization, first South Asia, they are prioritize conjunction awareness to reduce delay in dense and urban traffic. Second, Europe. They are focused on low emission road and supporting environmental sustainability. Third of example is United States. They are balancing highway speed with urban traffic efficient to maintain consistent travel time. By integrating efficiency, the energy management into design making, AI ensures sustainable safety and context sensitive mobility across diverse regions. Project objective and design challenging. The overarching objective of this project is to leverage AI innovation that is safety, adaptive, and efficient and human centralized. Horizon Robotic achieves this by combining with predictive analytics for anti-caption traffic and hard scenarios, localized intelligence for adapting to regional driving behavior and environmental conditions, design thinking ensure user-centered solution that prioritize safety and efficient to end the trust. Centralized designing challenge it is to how can AI think globalization but behave like localization, mirroring human adaptability while scaling across reserve environments. These challenges exclude the ensign of next generation autonomous system. AI must balance global intelligence and local contextual awareness to achieve widespread adoption, safety, and reliability. Project designing challenging question. To begin, the first question focuses on safety. In different countries, drivers behave differently. Some regions have more aggressive line changes, some have slower merging, and others have unpredictable motorcyclists. On top of that, environmental conditions like heavy rain, fog, or sudden flooding and distinctly changing the driving landscape. Talk the empathize of defined stage of design thinking. Horizontal robotic can use AI driven predict analysis to deeply understand these human and environmental factors. These include real-time traffic data analysis, intercept sensor information from cameras and LIDAR, and predicting potential handset before they happen. For example, the AI system can learn patterns such as when motorcyclists typically appear, how pedestrians behave in the business street, or have visibility change during heavy rain. It can translate this insight to safety and immediately vehicle response. By doing so, Horizon Robotic ensure that their autonomous vehicle not only follow rules but also adapt to the suitable real-world behavior of local drivers and making their safety protective rather than reactive. Second question. The second question addresses global scalability. Horizon Robotics aims to develop deeply autonomous vehicle across many countries, but each region has its own traffic culture. For example, driving style in Japan are calm and structured, whereas driving in Jakarta or Mumbai may involve constant line negotiation and decent traffic. During this edited of prototype phase, Horizon Robotic can experiment with machine learning models, large scale emulation, and scenario based on testing to build an adaptive employment model. This means the vehicle negative system routing behavior and decision making algorithm are not fixed. They constantly adjust based on the country or cities they operated in. By collecting data from local road, the vehicle can prototype new behaviors. For example, it can learn how quickly drivers accurate at the green lights, how closely they follow each other, or how often they use their horns. This approach allows Horizon or Robotic to scale global while respecting local horns, ensuring the vehicle feel natural and safety in the environment. Third, the third question at effectiveness and performance. Autonomous vehicle need to run smoothly and consume the less energy and operate reliability, but they must also maintain high safety standard. In the prototype and test stage, Horizon Robotic can apply AI forecast model to predict energy usage, traffic congestion, and component performance. For example, the system can forecast which route will be reduced battery consumption and adapt when sensor or forecast may be overloaded. Adaptive agents can constantly fine tune during driving speed, braking behavior, decision making to achieve these most balanced, beautiful performance and safety. As vehicle operate, they gather all their feedback, allow the AI to learn and improve over time. This is creation is continuously improvement loop, and the vehicle gets smarter and more effect and safer than every trip. Implementing the go to market strategy could do not. In the define stage, we focus on transforming raw data into meaningful insight. Here, AI play a critical role by translating traffic patterns, sensor input, and environmental condition into actionable strategy for the autonomous vehicle. Based on this insight, the system create dynamic operational profile that help vehicle respond intelligently in different environment. For example, the urban navigator profile prioritize conjunction handle and pedestrian safety in busy city center. The Suburban optimized focus on energy efficient routing for longer, smoother suburban roads, and the all-weather guardian activate during rain, fog, or low visibility, allowing the vehicle to adjust braking speed and detecting sensitive. Took this approach, autonomous vehicles do more than just follow a fixed route. They understand their surroundings and make smart and context-aware decisions. For the ideal stage in the global to explore solution and generate innovative possibilities. Horizon Robotic use AI to create predictive module and full-scale traffic simulation, allowing the company to test the refined vehicle behavior before real-world development. This simulation helped the AI evaluate different routing strategy, line changing patterns, and safety response under disaster conditions. For instance, in Singapore, the system can simulate adaptive line behavior for high effection expressway. In rain-prone regions, the AI practice predict braking and storm adjusted navigation for ensure safety handling. Importantly, these ideas are not created by AI alone. Human expertise is combining with mission intelligence to ensure that every stage remains realistic, reliable, and elegant with real-world driving horns. By blending human judgment with AI-driven prediction, Horizon Robotics developed smarter, safer, and more adaptable autonomous navigation system. Implementing the go to market strategy. First, define stage translating data into insight. Horizon Robotic begins by converting massive amount of traffic sensor and environmental data into actionable insight for autonomous navigation. This ensures vehicle respond intelligently rather than merely following strategy routes. Key operational profile including like urban navigator, optimize conjunctions management and pedal safety in decent city environment. Second, urban optimizer focus on energy efficient routing and smoother traffic flow in less contested areas. Or third, all-weather guardian. It's adapt to challenging weather conditions and maintaining reliability and safety. By understanding patterns and context, vehicle can anticipate and react intelligently, making autonomous safer and more adaptable across weird environment. Second, we move to ideate stage of co-creating with AI. In this stage, AI actively collaborate with the human experts to generate predictive model and traffic simulation optimizing routing strategy for Pacific region challenging. For example, Singapore implement adaptive line changing and conjunction aware route planning. Second, rain-prone regions use predictive braking and sensor adjustment to handle slippery route and reduce visibility. By combining human expertise and AI capability, Horizon Robotic ensure vehicle navigator intentionally, reliably, and safely tolerate to both environmental condition and region driving behavior.
Target market understanding localized AI needs. Next, I will explain how Horizon Robotics use AI driven insight to understand different markets across China, South Asia, and the Middle East. As the company expanded globally, it quickly discovered that each region had unique expectation infrastructure condition and religious environment. This means that a one size fit all solution will not work. To address this, Horizon Robotic realized an AI to transfer raw operational data into meaningful insight. This includes sensor feedback for vehicle details, vehicle log, edge device performance report, and analyzing generate from platforms such as IBM, Watson, Google Cloud AI, and customized telemetry system. Together, these tools allow AI to act almost like an empathy engineering, not just identifying that clients want, but uncovering why they want it. By understanding the motivation behind user behavior and religion challenges, the company can design solutions that genuinely match with needs of each market. In South Asia, the property in cost effectiveness and adaptability. Many areas are mixed road condition and inconsistent infrastructure, so AI models must be flexible, lightweight, and optimized for real world challenges. In Singapore, the expectations are very different. They focus in one precision, reliability, and seamless integration with a nation's smart city intensive. Here, AI support advanced traffic systems, strict safety regulations, and high performance navigation. Meanwhile, in Qatar and UAE, the emphasis in on robust, high performance system, the with extreme weather, long distance travel, and very strictly regulated requirements. By gaining this region insight, Horizon Robotic does not just sell products; it designs solutions that fit each country's operational reality. This ensures that development strategy, performance model, and AI behavior are fully aligned with the needs of each market.
Target market and understanding localization AI needs. From data to design, AI is the innovation engine. Horizon Robotic leverages AI not just to automate tasks but to drive innovation is product design and client engagement. Traditional market segmentation by size or budget is replaced with the focus on mindset cluster, technological readiness, innovation, adaptive. AI tools such as Google BigQuery ML, not proprietary simulation, have identified dynamic lines. For example, Elegant Innovator. They are startup and early adopter delivering modular AI for pilot programs. Second, reliability focused navigator. SMEs that prioritize proven long-term solution and partnership. Global expansion, multinational needs scale AI across diverse environments. AI transforms static market profile into dynamic guides, informing both product design and deployment strategy. Second, predict, predictive personalization for tailored solution. Beyond segmentation, AI co-design solutions that are customized to client usage patterns, operational data, and project-specific requirements. For example, Kuala Lumpur Edge AI for real-time urban traffic monitoring. Doha robust industrial AI designed for extreme temperatures and regulator compliance. Each deployment is personalized, reflecting their client's unique challenge and operational goals, ensuring that AI solutions are locally relevant, effective, and reliable. Robotics is one of Asian leading pioneers in age of AI computing for autonomous driving and smart mobility. Its mission is to bring AI to everywhere, developing hardware and systems that mimic human perception and behavior rather than relying slowly and raw computational power. Behavior intelligence focus is prioritize understanding and predicting human-like action on the road. Brain processing unit (BPU) it support advanced functionalities such as machine learning for adaptive design making, real-time sensor fusion to process multiple data stream simulation, low latency design making for immediate reaction, human-like perception and adaptation to complex environment. Collaborates with this automaker and city planner across China and South Asia, design AI that adapt to local traffic culture, weather condition, and road infrastructure, ensuring vehicle operate safely and effectively in diverse environment. Horizon Horizon Robotic is driving the evaluation toward context away, empathic, and human centered autonomous system, positioning itself at the forefront of scalable and regional adaptive AI in mobility. A collaborative ecosystem. Horizon Robotic defines its market not by client value but by AI driven insight and collaboration. Clients are treated as active partners participating directly in algorithm development and simulation and also deployment strategy. The key and rebel is design thinking plus AI. It's help combine human-centered design principle with advanced AI to ensure solutions are intuitive, reliable, and context awareness. Building understanding. AI learns how client operations are and regional condition, creating solution and tolerate to real world needs. Fostering trust. Collaborative development ensure transparency and confidence in AI performance. Last but not least, enhancing capability. AI amplify human insight and enable vehicle to operate safely, effectively, and in tune with local conditions. By integrating human expertise and AI intelligence, Horizon Robotics create a collaborative ecosystem where technology is both scalable and locally relevant, ensuring autonomous systems are trust, adaptable, and effective across diverse regions.
Next, I am going to continue present about tools. In this section, I will highlight the essential tools, software, and also resources that support Horizon robotic operation. So the company use enterprise-grade CRM systems such as HubSpot and also Zoho to manage global automotive relationship to ensure consistent communication. And for marketing tools like Canva and Meta Ads, manager help create professional technical content and reach key target audience, while Google Analytics provides insight into which region show strong interest in automotion's mobility. So one of the technical side is Google Cloud AI and BigQuery ML are used for traffic behavior modeling, while MATLAB and also Simulink enable simulation testing before real-world deployment. For example, like GitHub and GitLab then support collaborative development and firmware updates with OEM partners. Finally, platforms such as Shopify and the developer portal expand global access to AI kits, whereas TikTok and similar channels help engage the young innovation community. Together, these tools ensure Horizon robotic solutions are scalable, efficient, and also globally accessible. And the next is positioning. Horizon Robotics positions itself as a pioneer in localized human-centered AI for automotion driving. Its value proposition centers of creating AI chips and mimic human perception and decision making, allowing vehicles to adapt to cultural driving habits and unpredictable traffic conditions. The company's BPU architecture stands out because it incorporates behavior intelligence rather than focusing purely on computational performance. So its strong OEM partnership across Asia strengthen this positioning, and the integration of design thinking ensure that product development remains empathic, context aware, and also aligned with real driver behavior. So this positioning differentiates Horizon Robotics from global competitors by focusing on localized intelligence and also practical real-world adaptability. And the next is marketing strategy. Horizon Robotic marketing strategy focus on building credibility, educating partners, and also driving technical engagement. Email campaign deliver product update and also technical bulletins, strengthening long-term relationship with OEMs and developers. Content marketing supports through leadership, through articles, case studies, and white paper focus on localized AI perception and automation driving challenges. Video marketing humanize the brand through engineer spotlights on road testing, demonstration, and simplified technical explainers. So the social media strategy is multi-platform. For example, like Lincoln targets automotive decision makers, YouTube hosts technical contents, and TikTok and Instagram share shorts, educational clips, and Twitter deliver fast technical updates. So together these channels promote trust, brand visibility, and continuous engagement in high technology B2B environment. And the next is prospecting strategy. The prospecting strategy combines both inbound and also the outbound method. Inbound leads are generated through SEO, optimized technical content, research publication, and real-world developer case studies. So these elements attract engineers, mobility planners, and also automotive driving researchers who seek localized AI solution. So the referral program further strengthens trust based on client acquisition. Outbound initiative includes interactive demonstration booths, university hackathons, and active participation of International Mobility Conference. Private technical briefing allow Horizon Robotics to deepen relationship with OEM by demonstrating real-world performance. So this combined approach ensures that continuous pipelines of high-quality prospect while strengthening the company regional and also global visibility. And for conclusion, Horizon Robotics demonstrate how human-centered innovation can redefine the future of autonomous mobility. By prioritizing localized intelligence, the company enhanced safety, contextual awareness, and adaptability across device traffic environment. So the robust ecosystem of tools and resource support global scalability will strong positioning and strategic market ensure meaningful engagement with automotive partners throughout the proactive prospecting and continuous improvement. Horizon Robotics contributes significantly to the development of intelligent, sustainable, future-ready mobility system. So this alignment of technology, empathy, and also local relevance reflect a mature and innovative approach suitable for next generation automation driving.